Assalamualaikum. So today we go for eigenvalues and eigenvectors. This subtopic is the last subtopic in chapter 1. First, introduction. Let A be an n times n matrix. Why you have n? Wait. Okay, let A be n times n matrix and X be a non-zero column vector, a number lambda. So here the roots we call it as lambda. Okay, real or complex number is called an eigenvalues of A if AX equals to lambda X. Okay, we look at note here. AX equals to lambda X, same as here. Okay, it can be written as A minus lambda identity times X. So we factorize, we move X here to that side. Okay, so AX equals to lambda X, AX minus lambda X equals to 0. We factorize. Sorry. X equals to 0. So that's how you got A minus lambda identity. Lambda you have to times with identity because A is matrix, lambda is number. So you cannot minus that one. So you have to times identity. Okay. Move to theorem. Let A be n times n matrix. Then lambda is an eigenvalue of A if and only if P lambda equals to determinant A minus lambda identity equals to 0. Okay, characteristic equation and polynomials. Okay, determinant A minus lambda equals to 0. We call it as characteristic equation of A. Okay, at the back there. And next, P lambda is called the characteristic polynomial of A. Okay, P lambda. Next. Okay, procedure to solve eigenvalue and eigenvector. First, you have to find the characteristic equation. So, determinant A minus lambda I equals to 0. And then solve this determinant, and then you have to find the roots. What is the value for lambda I? And then solve the system corresponding to the roots. So this one system based on what is the lambda you will get. So this system based on this one. Okay, example, given matrix M, this one. Okay, find the eigenvalues of M and also for the eigenvector for lambda equals to 2. Okay, for this one, Okay, solution. First, you have to write down determinant a minus lambda I equals to 0. So next, determinant a, what is a? 1 to negative 1, 1, 0, 1, and then 4, negative 4, negative 5. Okay, minus lambda, and then I is 1, 0, 0, 0, 1, 0, 0, 0, 1 equals to 0. And then determinant 1 to negative 1, 1, negative 5, minus, okay, we expand 0 lambda 0 0 0 lambda. So this step dah terror, tak perlu dah buat. So determinant 2 negative 1, 1 negative lambda 1, 4 negative 4 negative 5 minus lambda equals to 0. So determinant, remember, you can use cofactor or sorus. Okay, let's say here we use sorus. So 1 minus lambda 2 negative 1, 1 negative lambda plus 1, 4 negative 4, negative 5 minus 55. Sorry, plus 5. Okay, 5 minus lambda, and then copy back column 1, column 2. And then using sorus, okay, we draw the line first. Okay, so 1 minus lambda, and then 5 minus lambda, plus the green one, 2, 1, 4, 8, negative 1, negative 4, plus 4, and then minus 4, negative lambda, negative 1, so 4 lambda, minus, okay, this one you have to write down first, 1 minus lambda because you have lambda, and then minus 5 minus lambda, and then 2. Okay, this one 1 minus lambda, negative 5 lambda plus lambda square plus 12 minus 4 lambda minus this one is negative 4 plus 4 lambda, and this one you have to expand 10 minus 2 lambda. Okay, then expand this one, 1 minus, so negative 5 lambda plus lambda square plus 5 lambda square minus lambda cube plus 12 minus 4 lambda minus minus plus 4 minus 4 lambda. Okay, this one you have to be careful with the lambda. Okay, so this one you can solve minus lambda cube 1 6 plus 6 lambda square, so lambda negative 5 negative 4 negative 9 negative 4 negative 13, so plus 2 negative 13 11, and then 12 16, so plus 6. Okay, solve this one using calculator. You will get lambda equals to, okay, lambda equals to 3 1 and 2. Okay, solve number 1. Next we go for question number 2. Find the eigenvectors for lambda equals to 2. Okay, we copy back the system. A lambda I x equals to 0. So this one dah dapat tadi. So we copy back 1 minus lambda, 2 negative 1, 1 negative lambda 1, 4 negative 4, 5 minus lambda, and then x is, you can use x, y, z, or you can use x1, x2 or x3, so mana pun boleh lah. And then 0 is 0 vector. Okay, substitute lambda. 1 minus 2 is, okay, we copy back first. 2 negative 2 negative 4 negative 1 1 5 minus 2. Okay, let's say I use x1, x2, x3, and then 0 0 0. So 1 minus 2 is negative 1 1 4, 2 negative 2 negative 4, 1 5 minus 2 3. Okay, copy back all, and then as you can see, this system is in the form of A, x equals to b. So to solve this one, we can use augmented matrix A, B. So A is negative 1, 2, negative 1, 0, 1, negative 2, 1, 0, 4, negative 4, 3, 0. Okay, first find leading one in this entry. So negative 1 times row 1, you will get 1 negative 2 1 0, 1 negative 2 1 0, and then 4 negative 4 3 0, and then make sure this one is 0. So R2 equals to R 2 minus R1 so 1 negative 1 1 0. So R2 minus R1 1 minus 1 0 negative 2 negative 0 1 0. Why this is 1 0? Okay, sorry. And then R3 minus 4 R1. So 4 minus 4 0 negative 4 minus 4 minus 2 negative 4 plus 8, so 4. 3 minus 4 is 1 0. Okay, and then you can see here you will get 0 rows, so 0 rows make sure at the bottom. So next we change R2 with R3. Okay, 1 negative 2 1 0 0 4 negative 1 0 0 0 0. Okay, kalau you rajin boleh jadikan ini satu, tapi dalam bentuk REF, ini dah dalam bentuk REF, so tak perlu sambung lah, just terus selesaikan. Okay, so you will get x 1 minus 2 x2 plus x3 equals to 0. This one for row 1. Okay, for row 2, for x2 minus x3 equals to 0. Row 2. Okay, but for row 3 you can see 0 vector. So how can you solve for x3? Okay, now for x3. So for x3 we doesn't have a leading one, so we have to use let x3 equals to any number, let's say t, and then t in a real number. So from row number 2, for x2 minus x3 equals to 0. So for x2 minus t equals to 0. So for x2 equals to t, then x2 equals to t minus 4. Next, row 1, you have x1 minus x2. Okay, you have 2. And then plus x3 equals to 0. So x1 minus 2, x2 is t over 4 plus x3 is t. Okay, so x1 minus 2, t over 2 plus t equals to 0. So x1 equals to t over 2 minus t. x1 equals to negative t over 2. So next we copy back x1, x2, x3 equals to x1 is negative t over 2, x2 t over 4, and x3 is t, and then you can take out the t. Negative 1 over 2, 1 over 4, and then 1. So this is the eigenvector for lambda equals to 2. Okay, thank you.